Problem number 4 states, a beam of light is incident on a glass-air boundary as shown below. Take the index of refraction of the glass to be N1 equals 1.390 and the index of refraction of air to be N2 equals 1.000. So for part A, they want us to figure out if the angle of incident light with respect to the normal is theta 1 equals 45 degrees, then what is theta 2, the angle of the transmitted light? So for this one, for part A, I've just drawn out our figure that they drew out for us, and we have theta 1 equal to 45, theta 2 is what we're solving for, and our indices of refraction. So for this one, we're just going to need to use Snell's law, which is N1 times the sine of theta 1 is equal to N2 times the sine of theta 2. And we can just plug in all those numbers. Theta is going to be equal to the inverse sine of 0.9829, which is equal to 79 degrees. So theta 2 equals 79 degrees. And then for part B, they want us to figure out how large would the index of refraction of the glass have to be for the total internal reflection to occur for theta equals 45 degrees. So for total internal reflection to occur, that just means that 100% of the light is being reflected back into the prism, and that occurs when theta 2 is equal to 90 degrees. So for total internal reflection to occur for theta 1 equals 45 degrees, we know theta 2 would be equal to 9 degrees, and that 45 degrees would be our critical angle. So we're solving for N1 in this part, solving for the new index of refraction of the glass, and we know our critical angle is 45, so we can use our critical angle equation, which is that theta critical equal to the inverse sine of N2 over N1. So we have everything other than N1, so we can just plug those in and solve. And for N1, we get 1.414. So that's how large the index of refraction of the glass would have to be for the total internal reflection to occur for 45 degrees, or for all of the light to be transmitted back into the prism. And this all ties into what we're learning in chapter 34 of ray optics, specifically total internal reflection.